Hi and welcome. I hope everyone is okay. Now, in this lesson, we will go on where we state in here. As you remember, we state in coded data for computing the mean. When we have the large data, we can use small data instead of the large data. As you remember, we have some numbers. If we want to compute the mean for these numbers, for example, 108, 103, 106, 107, and 104, the mean is 105.6. But for the numbers are large, and we can use the small number instead of these numbers. If we want to take a hundred less than all datas, for example, 108 minus 100 becomes 8, and 103 minus 100 becomes 3. So go on 6 and 7 and 4, and we can use these small data instead of the before data. We compute the small the mean of the small data. So 8 plus 3 plus 6 plus 7 plus 4 over 5, and we can find 5.6. But if we use 100 less than, all x, we find the mean. We find 100 less than the mean. So this number is the mean minus 100, because we subtracted all 100 all data. So we found 100 less than the mean. So the mean minus 100 equals to 5.6. If I carry out the other side of equal, so the mean becomes 100 plus 5.6, and the mean becomes 105.6. It's also the same before for using the large number. Please remember that. And we can find the same mean by using the small number. And please notice that if you want to use small number instead of the large number, and if you want to use 100 less than all data, you find the mean. You find 100 less than the mean. So 100 less than the mean, we have 5.6, and we can find the mean, the real mean, easily. And I want to tell something and please remember that we used to a sign for the sum of. Please remember that the sum of means sigma. Sigma is, you know, Greek letter. So if you want to compute the mean, equals to the sum of all x over frequency. But if you want to use the small number, and if you want to use 100 less than all data, you can find 100 less than the mean. So the mean minus 100 equals to the sum of 100 less than all x over frequency. And I want to show something about this situation. Okay, now I want to copy paste. Okay, now for example, we have these data, and we compute we want to compute the mean, and the mean is the sum of all x over frequency. But our numbers are very large, so we want to use the small number, and we want to use 100 less than all data. So the sum of 100 less than all x over frequency. So we find the mean 100 less than the mean, and we focus on I want you to focus on this situation. For example, the sum of all x minus 100 means 108 minus 100 plus 103 minus 100 plus 106 minus 100 plus 107 minus 100 plus 104 minus 100. And I want to arrange these processes differently. For example, you know, we have these data, and I want to show the same bracket, and 108 plus 103 plus 106 plus 107 plus 104, and we have 5 times 100. 1, 2, 3, 4, 5. So minus 5 times 100. 500. So I want to go on to arrange. For example, I can write this process: the sum of x minus 5 times 100. And please notice that the sum of 100 less than x, excuse me, equals then the sum of x minus 5 times 100, because we have 5 data. We have 5 data. So if we please imagine that if we have the sum of x minus 5 and the number of data, for example 10, so you can use this process instead of the before this process. So the sum of x minus 5 times 10. Okay, and the different example, the number of data, for example 20, and you want to find the sum of x plus 4, so you can use the sum of x plus 4 times 20, because you have 20 data. Okay, and now I want to go on where we state. Okay. Now, for example, we have some data, and we want to find the mean of these data, and mean means 95 plus 93 plus 96 plus 98 plus 99 over 5, because our frequency is 5, and I want to use calculator. 95 plus 93 plus 96 plus 98 plus 99 and over 5 becomes 96.2. Excuse me. And these result stay here, and I want to compute the differently. We have the large large numbers, so all numbers are near 100, and I want to use small numbers. I will subtract 100 all data. So we have I want to use x minus 100, and if we want to compute the sum of the x minus 100, and if we want to find the mean, we should divide it by it's divided by 5, because we have 5 data. But please notice that we find a 100 less than the mean. 100 less than the mean is here. Okay, because we use 100 less than all data, and we use 95 minus 100, 95 minus 100 becomes negative 5, and 93 minus 100 so becomes negative 7, and 96 minus 100 becomes negative 4, and 98 minus 100 becomes negative 2. 99 minus 100 becomes negative 1 over 5. But please remember that if we use to this process, we can find the mean minus 100. So the mean minus 100 is negative 12, negative 16, negative 18, negative 17, negative 17 over 5, and the mean minus 100 becomes negative 3.4, negative 3.4. So excuse me, 12, 16, 18, excuse me, 19. I have a bit mistake. 19 and negative 3.8. And if we want to 100 carry out the other side of equal, so the mean is 100 negative 3.8, and the mean is 96.2. Please notice that we could find the same mean according to before. So and I want you to remember one more thing. Please notice that if you want to x minus 100, you can use the sum of x minus 5 times 100, because we have 5 data, and we subtract 100 for all data. So 5 times 100 we subtract. Okay. Now we can use this situation if we want to use this process and to compute the mean. The sum of x minus 100 over 5, and this it means the sum of x minus 5 times 100 over 5. So this section equals to 481 minus 100 times 5, so 500 over 5, so negative 19 over 5. Please notice that we have the same value according to before value. Okay, and we have, this is negative 3.8, but to use 100 less than all x, we can find 100 less than mean. 100 less than mean, because we used 100 less than all x. Okay, so these results equals to 100 less than the mean. 100 less than the mean. So if we carry out 100 to other side equal, and the mean becomes 96.2. okay, we can use the different process instead of the large numbers. Okay, now we will make some practice about this situation. For example, we have 5 data, and we want to compute the mean, and also you can use this formula for finding the mean. 17 plus 12 plus 18 plus 13 plus 10 and over 5, and 70 over 5, it becomes 14. Okay, these stay here. If you want to use for example 10 more than all datas. 10 more than all datas. So you want to use 10 more than all datas. Okay, so you can find 10 more than the mean. 10 more than the mean if you use the sum of x plus 10 over frequency, and if we want to compute 17 plus 10 plus 12 plus 10, 18 plus 10, 13 plus 10, and 10 plus 10 over frequency, the mean plus 10 becomes for example 50, 50 and 120 over 5. The mean plus 10 equals to 24. And if you want to carry out to the 10 the other side, so it becomes 14, the same value. Maybe you want to use this process. The mean 10, the mean plus 10 means the sum of 10 more than all x, the sum of 10 more than all x over frequency. But if you want to separate this section, so the sum of x plus 5 times 10. Why 5 times 10? Because we have 5 data over frequency. So we have the sum of x, and we had computed this section. It means 70 you know, this section, it means 70, and I want to write 70 instead of the sum of x. 70 plus 5 times 10 over frequency 5, so 120 over 5, and it becomes 24. But 24 is 24 is 10 more than the mean, 10 more than the mean, so the mean becomes 14. Okay, and let's compute the different situation. Maybe you want to use twofold all x, twofold all x. So for computing the mean, the mean is the sum of twofold all over frequency. If you want to take twofold of all x, you find twofold, 2 times the mean, because you took 2 times all x, so you find 2 times the mean. Okay, and this situation, for example, 2 times, I want to use these numbers. Okay, and we have 2 times 17, 34, 2 times 12, 24, 2 times 18, 36, 2 times 13, 26, 2 times 10, 20, over 5. Excuse me, frequency. Our frequency is 5, you know, and we have 70, and we have 50, and 70 plus 50, 120, and 20, 70, and we have 50, 120, 140, 140 over 5. Okay, and we have 2 times the mean becomes 28, and if we divide it by 2 both sides, and the mean becomes 14. Please remember that the same value according to before process, and it doesn't change. Okay, it doesn't change. And I want to show another thing. For example, if you want to find 2 times x over frequency, it's also 2 times mean. You know, 2 times 17 plus 2 times 12 plus 2 times 18 plus 2 times 13 plus 2 times 10 over 5, and we have 2, and in the all data, so 2 times 17 and 12 and 18 and 13 and 10 over 5. Please remember that these process equals to the sum of x. So the sum of 2x over frequency means 2 times the sum of x. 2 times the sum of x over 5. Okay? So it doesn't change. And summary, and I want to some example about using sigma. Okay, about using sigma. For example, we have the number of 25 data. For example, 25 data, and if you have sigma x plus 10, you can use the sum of x plus 10 times 25, because you have 25 data. If you write x minus 2, you can use the sum of x minus 2 times 25, because you have 25 data. Okay? If you have 3 times x, and you can use 3 times 20x. Okay? If you use the sigma x over 2, you can use the sum of x over 2. Okay? And if you have different part, 2 times x minus 5, and you can use 2 times the sum of 2 times x minus 5 multiply 25, because you have 25 data. And also these 2 times the sum of x, because please remember that before example, okay, and minus 5 times 25. The different example, you have 3x plus, for example, 10. If it means 3 multiply the sum of x plus 10 multiply 25, because you have 25 data. Okay? And also if you want to find mean, and also you should use the sum of x plus 10 over frequency, but you find 10 more than the mean. Okay, because you used 10 more than x all datas. If you want to mean the sum of x minus 2 over 25, you can find 2 less than the mean. So 2 less than the mean. And if you want to find the mean, the sum of 3x over frequency, you find 3 times the mean, because you found threefold of all x, threefold of all x. And if you want to find the mean, and you used x over 2 over frequency, so you can find x, the mean over 2, the mean over 2, because you used 1 second of all x, 1 second of all x. Okay, the other one. And if you want to find the mean, and you used 2x minus 5 over frequency, so you find 2 times the mean minus 5, and 3x plus 10 over frequency, so you can find 3 multiply mean 10, more than 10. Okay, you can easily use the sum of the sigma for sigma easily. Okay, and the other section, if we have group data, how we can find the mean, how we can define the mean. Please remember that if we have group data, we used glass mean values. So this means x greater and equal than 5, less than 12. This means x greater and equal than 12, less than 19. This means x greater and equal than 19, less than for example, we have 30, because the last glass should be rated 10, 19, for example 30. Okay, and we have we used to this section, I think 25, to if this number becomes 25, it would be better. And we should use mid values for group data by using the mean. So our mid values this interval 6. So these values, mid values, are 11 minus 5 over 2, it becomes 3. Excuse me, plus, so 11 plus 5 over 2, it becomes 8. Okay, and 11 plus 19 over 2 becomes 15, and 19 plus 25, 19 plus 25 over 2 becomes 22. If we have group data, we should use mid values. Okay, and we want to find mean. So our data regards to x minus 5, and if we use the sum of all x minus 5 over frequency, we find 5 less than the mean. 5 less than the mean. So please remember that the sum of x minus 5, we should all data multiply the frequency. So this situation times frequency and the sum of all frequency. If we have group data, we have 8 values, and the glass mid value 8. So the sum of the first glass data, 8 multiply 8. We have 5 data, and the glass mid value is 15. So the sum of the second glass data, 5 times 15, and we have 6 value, and the third glass mid value 22. So the sum of data of third glass, 6 multiply 22 over frequency. The sum of all frequency, all data, 13 plus 6, so 19. Okay, and the mean minus 5, 64, 25, 132 over 19, and I want to use calculator, and if 64 plus 75 plus 132 over 19, and approximately 14.2, 14.26. So we can use, if we want to round that according to decimal, so 14.3. Okay, and for example, we have the other grouped data, and also we should use mid value, and I forgot the upper boundaries, so it should be it is 30. Okay, not necessary. And this interval, x greater and equals than 10, less than 16, this interval, x greater and equals than 16, less than 24, and this interval, greater and equals than 24, less than 30. Okay, and the glass mid value for the first class, 10 plus 16 over 2, it becomes 13, and 16 plus 24 over 2 becomes 20. 24 plus 30 over 2 becomes 27. Okay, and they give us 4x 4 times x plus 2 values. So if we want to find mean, we use the sum of 4x plus 2 multiply frequency over the sum of frequency, but we find 4 times the mean plus 2 because we used 4 times x plus 2. So according to mean, 4 times the mean plus 2. So this situation is we have 12 data and mid value 13. 12 multiply 13, we have 10 data and mid value 20. 10 multiply 20, we have 6 data and mid value 27. 6 multiply 27 over the sum of frequency 12 plus 10 plus 6. So 4 times the mean plus 2, 12 multiply 13, 156, and 10 multiply 20, 200, 6 multiply 27, 162. So the sum of frequency 28. Okay, and I want to use calculator. 126 plus 200 plus 162 over 28, 18.5 18.5 18.5. But this number is 4 times mean plus 2. So the first time we should carry out the 2 the others to the other side of equals sign. 4 times the mean becomes 16.5, and we should divide it by 4 for both of the equal sign, and the mean becomes 16.5 over 4 and 4.125. Okay, now we learned in this lesson using the different using the sigma differently, and we learned finding computing the mean according to different sigma process. As now for now our lesson finish. Have a nice lesson and have a nice weekend.